Hi there.
Hi, Eric. I thought you were going to say Happy Thursday, since it is
Hi.
actually Thursday.
It is actually Thursday. Well, I was actually thinking about that as the show was loading up, and I was thinking I always open with Happy Thursday, but maybe that should be a thing. Who knows?
We could just have it like a real intro. We could say, "Welcome to Rubber Duck Engineering."
Oh, welcome to Rubber Duck Engineering. I forgot.
We could share what the show's about. What's the show about, Eric?
Well, it's about rubber ducks, right? And engineering. I don't know. No, we stumble through and fail, and learn things every Thursday night. And I get to see you once a Thursday.
Yeah, speaking of stumbling through and failing, so last episode we wrapped up our Breakout project. And I think we just put a bow on that, put that on the shelf. And I think this episode we're going to start a new project. And we brainstormed a little bit before the show what project we were thinking about.
And we have the totally bestest idea ever.
So let me try to see if I can say it back to you, see if I understood it. We're going to do another Unity project because we're having fun doing Unity. We want to do a project where there are lots of things happening and they interact with each other. So we thought maybe we put all the things in a box, have them bounce around, and when they hit each other, something interesting happens. Like maybe they'll spawn more copies of each other, or maybe if they're different colors, they'll do something. I don't know. That's as far as we got in the idea.
Yeah. We talked about it being kind of Game of Life-y, but it probably won't look anything like Game of Life, and it'll involve multiple agents running into it. It'll be great.
We can introduce sound and do a fast forward transform. Just like
whoa,
put all the projects together.
Yes. You do have to understand. So part of what happened last week was that we're together in our 7 of Unity, but I went off and cheated, and did some other projects on the side. And so coming back to our original project was incredibly painful. It was all wrong. But we're going to do this one, and it'll be all wrong in a different way. It'll be great.
But we'll be all wrong together, and that's what's important.
Shall we together to the code machine?
To the code machine.
Dun, dun, dun. Oh, okay, there we go. I thought I pressed the wrong button, but I didn't. It is a brand new, fresh Unity project.
Oh my gosh. But this one's in 3D.
Well, I was actually I was going to say that because I learned through one of my tutorials that there's 2 things that are different between the 2D template and the 3D template. And I could go back and look at that tutorial to figure out what the 2 things are, but it takes 2 seconds to move from one template to the other.
To me, it seems like such a big difference about whether it's in 3D or not. But
well, some of it I think is whether this button right here is pressed at the start.
Whoa.
Anyway, so we need to make our cube, which I don't think you want to just make a cube and bounce around inside the things. I think we have to make probably 6 planes and bounce off the planes. I don't know that for a fact, but that's my guess.
Okay.
Another thing we could start with is we could just start with a bouncing ball.
Mm-hmm.
Seeing if we could make things bounce. Or bouncing whatever this thing is, sphere.
We just combine those ideas and put up the walls and drop a bouncing ball into it and see it bounce around.
Yeah, the single plane was just to simplify it, so we don't have to write the okay, let's position all 6 walls. But that also.
Oh, I see. You just want to drop the ball on the plane, have it bounce, and.
Yeah.
That sounds great.
Anyway, these I think we can probably handle it. So if we make a 3D object a plane, and then we add a 3D object a sphere, and we take our sphere and we use our little move tool to move it up. And if we hit play, what happens?
It floats there, as any good ball would do.
So I think we need to add a rigid body to the sphere to make it interact with gravity. Rigid body. Okay, so this should now make it bounce. Okay.
It fell with more bounciness.
Fell, yeah. So that's in the collider, I think. No. There's a place where you can set the bounciness.
We had a material before where we did this. I don't know if that was the right way of doing it.
That seems reasonable. Well, so let's make a. All right,
We
so
had a physics. I think we added a physics thing to.
Let's add materials. Make a new create material. We'll call this ball. It's not actually going to be a ball though. Let's add this to our ball, our sphere. And now you think that this thing. No, I think this is only involved in rendering, not in physics.
I see. Well, maybe I seem to remember we added some sort of physics component to this. Yeah, what have to say add component? Is there like a physics colliders?
I think we may need to look up where bounciness is set. I'm
researching over here.
Yeah, please do. I know it's just like a setting. Because I remember we said it, edit collider. Nope. I see, that's for editing like the shape of the sphere collider. Anyways, I know this is possible.
We could look at our other project and see how we did it. I mean, we had this like built-in physics, and then we decided to take it away and try to handwrite the physics.
How do you make a ball bounce? Physic material.
Oh, physic material.
What the heck is a physic material? Assets create physic material.
Okay, try that.
What?
Yeah, we had some sort of physical material kind of thing.
What the heck is a physic material?
I don't know, find out.
Novel to me. But sure, we'll create a physic material. Oh, I do remember that we made that, didn't we?
Yeah. Scroll down.
Physics material. Okay. Okay. So we want to make the sphere bouncy.
Oh, there we go. It went into your rigid body.
Oh, I see. It's like a sub thing on the rigid body.
It actually went into your collider. See, there's a material entry on your collider.
Oh, I see. So it's like a collider material, which is different somehow from like a rendering material.
That makes some amount of sense. Like I can see the analogy. So
if we put bounces to 1, that should just make it bounce forever, is my understanding. Maybe we have to turn the dynamic friction down.
Try putting the bounciness on the plane as well. I feel like this is sort of the same sequence of steps we went through before.
It's okay. This time one of the choices that we've made is that we want to actually use the built-in Unity physics and not write our own this time.
Mm-hmm. So this is good. Going good.
It looks like it's working. I don't know what the friction does. Is it getting higher? Is it adding? I think it's adding energy to the system. It totally is.
I think it is. It totally is. Which is what we wanted in the other project. And we're never able to
why it's adding energy to the system. Is it because they're both bouncy?
There's a bounciness of 1. I would assume that.
I don't know. Don't make us add our own. Whatever.
No. I think we should head down this path and see where it goes.
Okay, so now I think we need to make a script to set up the 6 walls of the plane, right? The 6 walls of the cube. The other thing we need to do is make this see-through. Right? That's another problem that we have to solve sort of independently. So if we make a new material, create a material for the plane, glass or whatever. I
Mhm.
think it might be. Let me take this on the plane. I'm just trying to like set up the pieces.
Yeah.
Rendering mode, transparent,
Okay.
maybe.
That's good.
And then we have to make this also transparent. I was cheating and I read a little bit on the interwebs. So theoretically,
It's not cheating to read things on the interwebs.
If we, I can't see a thing at all. Okay, so that's on top, I think. I mean, I don't see it. Do we have a light in our scene? We do have a light in our scene. I think our glass is good enough.
We can also make it slightly tinted if we want to keep track of it while we're working.
Yeah, we can also make it draw wireframes and stuff like that. The other thing we could do with this glass, whoops, I see I changed the color. Like we could make it like slightly blue or something like that, right?
Yeah, give it an alpha that's just.
But give it an alpha that's like not.
Yeah, something like that looks good.
So I still can't really see it. I don't really understand where it is here, but whatever.
Maybe looking up.
I'm not as good with this view as I would like. But that's looking from above? Yeah, I'm looking top, right? So if I look, that's back. We can't see it. And if I look below, oh, can I see it now?
You can see a little bit, yeah.
Well, whatever. I think we can apply it. We also, theoretically, there's this way to make like a skybox. I don't really know what the skybox, like somehow maybe a skybox is applied. There's some way to like tell the camera what to render when nothing is there. Like I think that's what the skybox is.
Mm.
This is something I hear tutorials various throw around, but I've never actually played with it.
Do you want to look at the camera rather than the light to try to?
Oh, that might be related to it. Clear flags. Maybe that's what I'm talking about. Clear the idea of what are you clearing the scene with?
Oh,
what are you clearing the buffer with? What?
Are there other options there? I see a little drop down.
Yeah. So like we could set this to
everything's taking place in a purple universe.
Sure, why not? But this also allows me to theoretically see the. Oh, I see. I'm not gonna see the skybox in this. Whatever. I think we can keep. I actually probably can make it show me the skybox. Not with the gizmos. Well, the gizmos will show me the plane. You can see we're learning Unity slowly, one click at a time. All right, let's make our cube.
Okay.
So assets, let's make a script folder.
So you want to make the cube in code as opposed to making it in the editor?
I think that's the Unity way to do it.
Okay.
Just in the sense, because it's like something that's programmatically generated as opposed to like you would be able to set the size of the cube. So the way I'm going to do it is I'm going to create an empty object here.
Mm-hmm.
And this is going to be, I learned about the rename key, by the way, which is supposedly a Microsoft system, I think. F2 is the rename key.
Oh yeah, that's totally rename all throughout Windows.
I had no idea, but that's how you rename things in Unity. We can call this the Thunderdome.
The place where everything will collide.
And the Thunderdome is then like our Thunderdome script, right? And we add it to the Thunderdome.
Mm-hmm.
And so then on start, we're going to want our game object wall prefab. Right. This is public. And we're going to want to instantiate one just like we did before, right? Like,
well, before we try to tie it to the screen, I don't think we quite want to do that. I think we want to just put it at 1, 1, and 1, and then use the editor to size it.
Or better yet, public float radius.
Okay.
So we need to avoid create wall, and then vector 3 like position. I actually don't know if this even needs. I think we can just do this, right? We instantiate. Remember what the call is?
Yeah, you want to instantiate. You want to instantiate the wall prefab at the position that you have in mind.
I think my autocomplete is broken again. One way to commonly fix that is to do this.
You got to generate your solution.
I think what happened was that I opened it before I had any scripts. We may just be living without autocomplete this time. There we go.
Do you want to instantiate this thing as a child of?
I don't know that you. Is there a way in the instantiate to set it as a child, or do you have to set it as a child afterwards? I think you have to set it afterwards.
Okay.
Let you know one.
Well, I was just looking at the instantiate documentation, and you actually can.
Oh, well, teach me, Obi-Wan.
So that now you're going to use the 4-argument version of instantiate because
right
you're
there.
awesome.
Yep, there's a parent.
That one.
I think I've been watching tutorials that are 5 years old, which may not have had this method. It's funny actually to watch these tutorials where they do these convoluted things like, why do I have to do it this way? And then like you see in later Unities, well, they've just created a method to let you do it. It's good that they're listening to their users. So I don't know how to calculate all of these.
We just want to say like minus x, minus y, minus z, right? There are going to be 6 of them. So you can say new vector 3.
I wonder if the like vector 3 dot, that's going to be.
Oh, you can just multiply that by the radius.
Well, you can multiply that by the radius, sure. But.
That's great.
Right, for the position.
Yeah, for sure.
This also seems to be the Unity way. Like you use one of these built-in things and you multiply it by. Again, from my minimal amount of tutorialing. So, but that doesn't. But now we have to also set the. Oh, you know what? We could do. Vector 3 dot. Look at.
Oh, for the rotation. I see.
I don't know. Like the rotation, there may also be a way. There's like a look at method.
You want to search for it? All right, search for it.
I don't remember how to look at.
Oh, it's a transform.
Oh, maybe it's an instant method on transform. That's not what we want.
Well, we have a transform, right? Like for ourselves.
It's going to modify our transform. Well, there must be some cutesy, quick Unity way to get these 6. Like this must be a common thing.
You're trying to get them all pointed in the correct direction. Is that the idea?
Yeah. Right. So if we extension these, so like say I put quaternion identity here, right?
Yeah.
We can just try this, but it's going to be wrong. This is transform, right? So say I do this 6 times.
Mm-hmm.
It's like
up, down, left, right.
Down. Okay, start.
Yeah, really.
It seems like back and forward. This one? No, that's all. But we still have to do the angles of rotation, right?
Well, we have to scale them, right? Right. Well,
scale them by radius.
Yeah.
All right, well, this gets to like create wall, right? Would create. Like maybe you can bounce around inside a mesh, inside a cube. I just feel like if it were inside a cube collider, it's not going to produce the right behavior.
Mm-hmm.
I don't think you want to start inside some other collider. I think you want to be...
No, I think you're doing the right thing here.
So this is vector 3 position, vector 3 angle. It's actually not vector 3, right? It's quaternion.
I mean, I feel like you should just do this. Like, what if you instantiated it at the origin with its default orientation? You told it to look at the vector that you were going to position it to, and then you moved it in that position.
Well, or you could just also start it and then just grab and look at, right?
Oh, I see.
Right?
Oh, I can then have it look at the origin, basically.
Yeah, it's a little cheating, but sure. I think this actually makes a lot of sense.
It's cheating at all.
Var plane. So now you do plane.transform.look at.
Yeah. Vector.0. Vector 3.
Transform.position, right? In case we got moved around.
Oh, I see. Yeah. Yeah. What's wrong with that?
I think that looks great. But we also need to scale it up, you said, right? So we need plane.transform.local scale.
Equals radius, I think.
Except it's a vector 3, right? So it's vector 3.1 radius. This feels very Unity to me. There may be a better way to do this, but vector 3. Look at us. We're like writing code.
I mean, this code looks pretty. I don't know what it's going to do, but...
Oh, I think this will work. But I think most code that I write works, and then it doesn't. So let's see. Okay. So this is going to be 0 to start with. So it's not going to display anything at first.
Is the start code going to run in the editor? No, we just have to set these properties in
the start code will run in the editor.
Really?
When it's first brought into the scene.
Whoa.
I think. So we could add an editor script, but I don't think we need to go there. It's not going to... Making those public and stuff isn't actually going to help that much. All right, so we want Thunderdome. It is 10.
Sounds good. We just set the wall prefab.
Set the wall prefab. This does not go here. This goes in. Prefabs. Scripts. Prefabs. Okay. Thunderdome. Whoa, it's got like a light. It's like a sun or something. It's kind of pretty. It's not doing exactly what I thought. But you're right. Maybe the start method isn't?
No, it was there. So why don't you take out the one plane that we have already?
Oh.
But now run it. If you looked inside your Thunderdome, they're there. I don't know where they are. Can you click on them and see what their parameters are?
Oh, they're like...
Those numbers are way crazier than I thought they would be. Are they all on top of each other? They got their scale, so that's good. They all ended up with the same rotation and position, which to me is strange.
Well, the position seems wrong.
Oh, it's always up. You wanted to put in position. Okay.
But even still, it shouldn't have been...
Well, let's try this. I'm curious what the Thunderdome does here. All right.
My code was perfect.
Can we click on it and see what their parameters are? Can we try it without the lookat code? I feel like the lookat code is the code I understand the least.
Well, it's also the code that's clearly doing the wrong thing here.
Oh, it's after the scale. That's why. Try putting it before the scale. I don't know if that's
I'm
going to
not
matter.
sure that that's actually going to matter, but because it's a local scale.
Yeah, okay.
We still have our snowflake. But let's turn this off. But yeah, so they're working. They're just all.
Can you click on them? And I want to see what their numerical parameters are. I'm a numbers person.
Yeah, this makes sense.
Where is the Thunderdome positioned? Yeah, the Thunderdome is not at 0, 0, 0, which I think may be part of what's making this complicated for us. Why do they have such strange positions? Oh, sorry. I think you reset the Thunderdome's position in the play mode, not in editor mode.
Thank you, Unity. Why are you like a bright different color when? Okay.
That looks good.
They're all set correctly.
Why is there... oh, I see. Because they're...
It seems like their scale versus their position is wrong. It's not the same units.
Right. Maybe because the scale affects the position.
The scale is local. They're huge, by the way.
They are ginormous.
Is it possible that it shouldn't be scaled in all directions?
Let's see. It itself has a scale of 1. What if we don't apply the scale? What does it look like? Oh, vector 1. That's why. You want a oh, I see vector 1.
You just want to scale in the X and the Z, not in the Y.
Well, let's take the scale off and see what it looks like. But yeah, I think you're scaling in. Well, but it's a plane. It shouldn't matter when you scale it in the. It's flat dimension. It's flat. That looks pretty good. Like,
yeah, that looks correct. I mean, minus they need to turn orientation.
Where's there's a 6th one, I guess, which is...
Oh, interesting. Well, eventually it'll hit it.
As it gains energy.
But they still need to...
Can you click through them? I want to see the parameters again. Yeah, it's like funny that it's 10 and 1. Okay, can we add the lookat code back?
The lookat makes the front face the center. So I think it's actually going to do the wrong thing.
Oh, we want to look at the opposite somehow?
Well, we want to make like the Z lookat. Yeah. Yeah, so it makes front. So we would need to be like 90 degrees.
Okay, we can rotate it 90 degrees. Or maybe there's some other way of...
So if it makes front...
There's a rotate command. Oh, there's a second parameter you can pass
To look at,
which is up.
Oh, world up.
Specify.
I see. So we want like, we want it to think what do we want it to think? Like, what happens if we put vector 3 up here? I bet we actually don't want vector 3 up. We want like vector 3
down or something,
or back or something like that.
Vector 3 up is the default.
Yes, we want.
The example they give in the example is vector 3 left. I don't know if that is at all relevant to what we're doing.
Geometry is hard. Yeah, that's not correct, I don't think. We can name these things, right? Oh, whatever. All right, so
we can also just rotate it. Like we're trying to use this lookout function in a fancy way, which may not be necessary.
Mm-hmm. So normally a plane is flat forward, and we want, it's over here, it to point its
when we move it down, we don't want it to do anything. When we move it up, we want it to rotate it 180 degrees about the
but when we move it down, it's actually going to look straight up. So we want it to think that its up is what does it mean to change what it thinks up is?
Is it also possible for us to just instantiate a plane ourselves?
Well, we're added energy, we bounce. Yeah, we can totally instantiate a plane ourselves. Trivially.
I just wonder if that may be easier than trying to figure out how to rotate an existing plane.
New plane.
Oh, I see. It's just a primitive type plane.
Yeah, I mean, I don't know. Like, yeah.
Yeah, that's not going to help
just the
us.
class, right? In normal. Oh, that's right. Because you just specify. Yeah, this is exactly what we want. We don't want to. Well, the normal.
Oh, we can set the normal?
Get side, same
Oh,
side, set
flip.
sides.
There's a flip operation on the plane.
Set normal and in point. In normal, in point. So, like, what happens if we just do, how do we get all the stuff from the prefab, though? Like, we want its materials and stuff like that. Create cube with
Okay.
buttons.
Okay, I have an idea. There's a function called rotate around on transform.
Meaning?
Meaning, if we move it always down, right? And then we can rotate around the origin to the place we want it to be.
We move it down. Okay.
Yeah, so always instantiate it at position down.
Okay.
Down times radius.
Mm-hmm. Yeah.
Okay, and then depending how much we want to rotate it, we'll rotate it around the origin. Yeah, so try plane.transform rotate around.
No.
So always passing the origin, so vector 3.0.
Yeah, but
Sure. Well, you're okay. This is fine, but and then
I see. You're right. Yeah. Okay. Okay. Otherwise, I have to pass the vector 3's relative to that. So yes, you're right. I just want to do vector 3.0.
Yep. And then let's say the axis is up.
So that should be this direction parameter, right?
Mm-hmm. And then put in like 90 degrees.
I know this may seem silly, but I actually think we're learning a lot by doing this. So I'm glad that sort of glad that we're spending the time doing this. So the first one is up.
It's weird to me that we got different answers.
These are in the same spot.
But okay. Was there? Can I look at your code again? Like what? I was expecting them all to come out the same. What did you use your argument for?
This rotate around.
Oh, I see.
Oh, rotate around. Well, hold on. Rotate around is which local point to rotate them around? Or rotate around point axis.
Mm-hmm.
Yeah, so you're picking a point and you're picking an axis to rotate around at an angle. I don't think that's what you want.
But yeah, go back. It worked out pretty well. Like if you go back to what you're doing,
Mm-hmm.
like we have 4 sides of this box.
Where's the 6th one? Oh, they're both stacked down here for some reason.
Yeah, so only one of them messed up.
Somehow the up
down,
and down ended up being the same.
Yeah, up and down ended up being the same.
Which doesn't make a lot of sense, but okay. They make this so easy looking in the tutorials.
Well, they already solved all the problems. What if you instantiated it at the origin?
Uh-huh.
Okay, here's my new plan.
Yeah.
Instantiate at the origin, rotate it, and then move it locally out to where it's going to
go. Move it locally?
Mm-hmm. So first rotate it, and then translate it.
Oh. I mean, the whole thing is that we're just trying to cheat and write it quickly. We could just write out all of these.
Let's try that. I think we should try it.
Okay. So
just instantiate it at 0, 0.
Mm-hmm.
Yeah, call regular rotate.
Oh.
So pass in your direction.
The Eulers are going to be in degrees, I think.
Yeah, okay. So we'll multiply by 90.
5. I see. Oh.
Yep, that's it.
Relative to.
You don't need to pass. That's fine. The default is fine.
Okay. This has a chance of working.
Wait. Then you got to go translate. Translate vector 3.forward.
Forward instead of down, or
I don't know. You got me.
All right, so that's up, down. Or which one?
Try up instead of forward. Can you go through? What do we got?
I'm already composing tonight's tweet in my head. We made a cube.
I think we
spent an hour making a cube. What?
Wait, this whole like grandiose idea, this whole like thing we were gonna build.
It's totally gonna be.
We spent the entire time just trying to assemble a cube.
It was like 20 minutes ago that we first wrote the first version of this function. Okay.
Okay, can you just go through this? See what we have? We have rotation X. So that one is 90, minus 90. Okay, that's good. What is the next one?
This is up, right? So up is...
Yeah, just move it 10 instead of 1. Well, we could try editing it in the editor, but
okay, there's that one. They're both up there for some reason. Yeah, why do they both... Like, what is up?
Try direction time. Just try to translate in direction and see what happens.
No, it's just up and down, as though they're like special somehow. I see. Those are -1. Those are the... Like, what is going on? I don't understand why those two keep being in the same spot.
Okay, let's simplify the equation. Let's take the translation out.
Yeah?
No, keep the rotation in. That's good. Let's get rid of the translation.
Yeah?
Yep. Right. So we've succeeded in creating the shapes at the right place and in the right orientation.
Wrong axes for these.
But that's good. What's wrong with that? Those are mirror images of each other. And what are the other ones? Yeah, they're flips of each other. And the other ones are flips of each other. We just need to put them in the right position.
Those are not flips, right? See, the z-axis isn't flipped. That's the weirdness. I wonder if this is like a 0-360 thing going on. This one also.
I just feel like we're really close to a cube. All we need to do is move them apart from the origin.
But the direction, right? So if we say we move them both along the z, they're gonna go along the same z. Whereas this one, when we move them both along the z, they're gonna go in different places.
Yes, try it. You just try it in the editor. Try editing their position.
I'm sorry, you want me to like...
Yeah, put 1 there. Yeah, so that's clearly wrong. We don't want to move that one along Z. We want to move that one along Y.
I see, because Y is the green one.
Yeah, and Y is going to be the same. We'll move 1 in positive Y, 1 in negative Y. It's going to work out.
Well, this is the 90. Maybe 90 is the wrong rotation, or maybe we're rotating a wrong, like this, rotate. Like, what axis is this? Oh, I see, we're rotating along the same... We're rotating around the axis that we want to move them. That is the wrong thing to do.
Oh, we want something perpendicular to that?
Yeah, the confusing thing about a plane is that the way we think about it is for its normal. Like, if we were just instantiating using the plane, like, I think we would literally just do this. We would do new plane, direction. Like, at that point with that normal.
Okay.
Like, I think that would probably create the cube. But the problem is then we drop our prefab. Maybe there's some way to, like...
Can we find the plane in there? Like, does the game object have a shape that we can just directly manipulate?
I want to see what the overloads are. No. What do you mean?
Well, I'm just wondering if we could go just edit the plane. We know there's a plane inside of there. We could go find it and do exactly what you just said.
I think... I think the look at thing would actually work. Maybe I'm taking us, like, if we just set, as you said, but like vector back or something like that.
Okay.
What did I do?
They're all the.
I not? Oh. Maybe it doesn't have to change because it's not in any translation. It doesn't have to look at anything because it's already at that point. I we literally are going to have to spend an hour trying to build a queue.
I have another question. We
Yeah.
could just type in the things we want in the editor, right? Why are we trying to write all this code?
But we were trying to learn geometry.
Geometry.
Okay, let's do it. Let's do it. Let's build the Thunderdome by hand. And we'll come back to this later. The lost episode. Okay. Turn you off. Thunderdome failed script. I hope this isn't an interview question. Because I failed.
The geometry is hard.
No, don't be a sub. I can't. Okay. Did we do it?
I think we did it.
Did I make too many? Why are they both named plain? Like, what's going on here?
Right.
I dropped them in.
We just name them left, right, bottom, top, right. So like,
All right. Left. What
we
is
can do
left?
it.
I want. Okay, left. I want to go negative x. Why am I doing this? But now we can't scale them.
Why not?
Here. Negative 10.
Okay. And then you want to rotate it, right? Wait, let's just get it all in the right place here.
We want to rotate it around the z.
Okay.
That doesn't make any sense. Why is it? Isn't z up? No, y is up in Unity. Oh, I always forget that. Y is up in Unity. So we want to rotate it around the z, which is going straight. So we want z90.
Okay.
It's hard to see it.
We did make it transparent.
I mean, I can trivially change that. I go back to the materials. What? Did we not create the material for it?
Just the glass material is the material.
Oh, glass. Right, so. Where is it?
I think you're looking at it edge on. Like you're.
Oh, yeah. Okay.
Okay. So let's try to do right.
Okay, and so this is going to be positive x.
And negative rotation.
And sure, around the z. And scale, we don't know yet.
Let's not do the scales quite yet. Yeah.
Okay. top. I cannot believe we're doing this by hand.
We're learning. Sometimes you have to do things by hand before you.
Yeah, we go down, and we're okay. So now this is going to be positive 10. Why?
10 or 1? Were you doing 10 before?
I don't remember.
No,
it's not a constant in our code. But we did.
We did both because we're amazing. Okay. But do we need to?
I don't know. Where does the green always faces out?
The green's going to face out. Okay, cool.
The Y, that is. Okay. And now this is bottom.
Right. So now we're learning why these were the special ones. The top and bottom ones are special.
Because they're aligned with the axis no, they're not.
Well, that one had a rotation of 0, and this one's going to have a rotation of 180.
That doesn't seem right.
No, the rotation is going to be around X.
The rotation is going to be around X, yes. Was the other one on X?
Well, it was 0, so you couldn't tell.
Okay.
You have to give it its offset, its position offset.
Okay.
Yep.
Then this one's front and back, right?
Mm-hmm.
Okay, so front is going to be, so we're looking at this from the back. So it's going to be positive Z. And it's going to be rotated around the X.
Y.
No, around the X. What?
Around the X. Okay, around the X.
Yeah.
Yep.
90.
Okay.
Except that front. Okay.
That's good.
That's good.
So that means we messed up bottom. Go back to bottom. We can finish this, but yeah. Bottom should have been 180 around Z then.
Okay.
Yep.
And so this is going to be negative 90. And it's going to be negative 10.
I think Y, Z instead of Y.
So there was something that I learned in one of my tutorials about how Unity's rotation system is weird. It's 90 degrees off from what you think it is. And you have to like translate from Unity coordinates to like normal person coordinates. But I'm clearly not remembering well enough to convey it.
Okay, should we set the scales properly? So our box will...
What the scales should be. Like they clearly should be...
I think it should be... Let's just try it. So
like it looks like it should just be...
So Y is the green one, right? So that means the scale...
So Y is always 1, but these are like 2. You're like, why do we move it 10, but we scale it 2?
Its intrinsic size must be 5. Like that's the only answer.
Yeah. I see.
Yeah, so the scale is always the same in its local coordinate system. That makes sense.
I'm getting back to composing the tweet in my head. We made a cube!
A cube!
Manually!
Okay, so I think the position things made sense. Now the question is how to, like, it's interesting that some of them are 90 and one of them is 0 and 180. I think that was the thing that was tripping us up, is the fact that it's less uniform than we thought.
It gets to the Unity weirdness that I'll have to go. I'll go dig up that.
Well, I think it's because a plane is biased, right? A plane has one direction that's not like the others. And somehow that's coming out in the rotation number.
9 o'clock at night, my brain just can't. Sorry, my kid wakes up really early. So we have the Thunderdome.
Okay, can you press play? Does it work?
Well, we got to make it transparent so we can see it. Oh, stop hitting the dropper, Eric. The dropper does not help us. Like, why do they have the dropper there? Like, when they, what, I mean, okay, fine, whatever. I don't need a rail. Okay. Thunderdome. Oh, we gotta back up the camera here.
The light is passing through the Thunderdome and being affected by it. I think it's neat.
Okay, I backed out the camera.
We totally got to rotate a little bit, the camera. I think it was off 580 degrees.
We're passing through it from below?
Yeah, try flipping all the rotations by 180 degrees. I think we want all the
Y. The Y up. Because it's biased again. Okay, so this needs to be 270?
Just negative 90 is cool.
Negative 90. Maybe. That one.
That one, right, that one's got to be 180. The box is now taking a little bit more visual shape, which is interesting.
Yeah, it's interesting. There's clearly like a...
It makes sense that the bottom isn't rotated, right? All we wanted to do is move the bottom down, so that's cool. It's getting to be more sensible.
Okay. Okay.
Thunderdome. Thunderdome.
I'm sorry, we're getting to the Christmas episode now. Okay, in our overtime, can we make it not be straight on? Whatever. Okay, whatever. I think we have a thing. We have a Thunderdome with a bouncing. So next episode.
We'll put a second ball in the Thunderdome. It will take an entire episode.
No, next episode we're gonna spawn balls because we know how to do this from our last our last shenanigans, right?
I'm into that.
We're gonna spawn balls in many directions, and then we can teach them to bounce off each other. I think making the cube was the hardest part.
No, I think each time it's gonna be equally hard. This is great. I feel like I learned something today.
I do too. Like if I was coming home to my wife after this is a day of work and I had to explain to her, what did you do today, honey? I made a cube.
I spend equal amounts of time at work on similarly things afterwards.
Yeah. Well, our cube isn't going to be used by millions of people, but anyways, this was amazing. As always, Dr. Barth.
I will see you next week.
See you next Thursday. Take care.